Imagine a world removed from sun and sky. A place where gravity feels different, and the very air you breathe is recycled within a steel shell. For one man, this wasn't a nightmare, but a daring vision. A challenge to humanity's limits. He would descend into the icy depths, not for hours, nor days, but for weeks on end. 73 days. Without once touching the surface. What compelled such an endeavor? What secrets would the deep reveal about human resilience? The answers would redefine our understanding of survival. His name was Dr. Joe McInnes. A physician, an oceanographer, a true visionary. In a world captivated by space races, McInnes turned his gaze downwards, to the vast, unexplored oceans. He believed that to truly understand human capacity, we must push beyond the familiar. His idea wasn't just about discovery, it was about human endurance. Could a person truly thrive, or even merely survive, in such an alien environment for an extended period? His experiments sought to unravel this profound question. His chosen home for this unprecedented mission was the subigloo. Not a submarine, but a compact, pressurized habitat designed to cling to the ocean floor. Picture a small, self-contained world, just large enough for one. It was his sanctuary, his prison, his laboratory. Located beneath the Arctic ice, its walls offered a fragile barrier against the crushing pressure and the numbing cold. This was where life would unfold, day after day, in isolation. What did it feel like to call such a place home? The moment of entry. A final breath of surface air, then the slow, deliberate descent. As the subigloo settled onto the ocean floor, a new chapter began. The vibrant world above vanished, replaced by a muted, eternal twilight. The sounds of the surface faded, leaving only the hum of life support systems and the gentle creaks of the habitat. This wasn't merely a dive, it was a psychological threshold. He was truly alone, disconnected from everything known. The vastness of the ocean, his only companion. Within the subigloo, a peculiar routine emerged. Days blurred into a continuous cycle of observation, maintenance, and the fundamental act of existing. He documented his environment, monitored equipment, and performed scientific tasks. Every action, every moment, a part of the grand experiment. His world consisted of instruments, walls, and the ever-present view of the dim, blue-green depths. How does one maintain sanity, purpose, when the outside world is a constant, unchanging abyss? Beneath the surface, hidden from plain sight, Dr. McInnes's body began its own silent transformation. The absence of natural light, the limited movement, the unique atmospheric conditions inside the habitat all conspired to challenge human physiology. Muscle atrophy was inevitable. A slow, insidious weakening. But a more alarming change was also underway, deep within his skeletal structure. The true cost of this isolation, beginning to reveal itself. What was happening to his very bones? The sensory world within the subigloo was profoundly limited. No fresh breeze, no vibrant colors, no shifting landscapes. Just the muted palette of blue, gray, and the sterile interior. The relentless monotony could erode the sharpest mind. Time itself began to warp. Without the sun's rhythmic rise and fall, his internal clock, his circadian rhythm, struggled to find its footing. How does the human brain cope when deprived of the very stimuli it evolved to process? Perhaps the greatest challenge lay not in the physical realm, but within the confines of his own mind. Extended isolation, the constant confinement, the sheer weight of knowing he couldn't simply leave. These are conditions that test the very fabric of psychological resilience. Thoughts can become magnified, fears can loom larger. He faced an adversary as vast and formidable as the ocean itself, the human psyche, pushed to its absolute limits. How did he maintain mental equilibrium? Meals in the subigloo were far from gourmet. His diet consisted primarily of freeze-dried foods, lightweight, long-lasting, but utterly lacking in variety or sensory pleasure. Every nutrient was carefully calculated, every calorie accounted for. This wasn't about culinary enjoyment, but pure, functional sustenance. What impact did this monotonous, processed diet have on his body over 73 days? Beyond the physical, how did the absence of fresh, comforting food affect his morale? While McInnes was alone in his underwater world, he was not unwatched. A dedicated team of scientists on the surface meticulously monitored his every vital sign. Biometric data flowed continuously, a silent testament to his living experiment. Heart rate, oxygen levels, habitat conditions, every piece of information was crucial. They were tracking the subtle shifts, the body's adaptations, searching for patterns, for anomalies. What were these silent observers hoping to learn from his incredible ordeal? As the days turned into weeks, one particular physiological impact became increasingly evident. The lack of gravitational stress, the reduced physical activity, began to exact a significant toll on his bones. Scientists observed a staggering 20% loss in bone density. This was not merely an inconvenience, it was a profound alteration to his skeletal structure. A stark reminder of the body's dependency on constant stimuli. This finding had implications far beyond the deep ocean. Alongside the bone density loss, muscle atrophy was a constant companion. Without the varied demands of a terrestrial environment, his muscles, once finely tuned for movement, began to waste away. This wasn't about aesthetics, it was about function. Strength diminished. Stamina waned. Each day underwater reinforced the critical link between physical activity and the maintenance of a robust human form. What would his body be capable of when he finally returned to the surface? Beyond the significant changes, everyday life underwater presented its own unique irritations and health challenges. Constant humidity fostered skin problems. Ear infections, a persistent nuisance, were a direct consequence of the environment. Each minor ailment, though not life-threatening, contributed to the overall stress. They were constant reminders of the alien world he inhabited. The body, constantly fighting to maintain equilibrium. What other unforeseen consequences would emerge? The similarities between McInnes's underwater ordeal and the challenges of long-duration space missions were uncanny. Confinement, isolation, sensory deprivation, altered physiological states, these were shared frontiers. NASA recognized the profound implications. The subigloo became an unexpected analog. A terrestrial laboratory for understanding the limits of human adaptation in extreme, isolated environments. Could McInnes's solitary journey provide a blueprint for journeys to distant planets? Why endure such hardship? The ultimate goal transcended personal endurance. It was about pushing the boundaries of human survival research. McInnes was a living dataset, providing invaluable insights into how the body and mind adapt, or fail to adapt, under extreme stress. Every ache, every thought, every biometric reading, contributed to a larger understanding. A puzzle, slowly coming together, to unlock the secrets of humanity's future in hostile environments. What grand design was he helping to reveal? As the 73rd day approached, a new wave of anticipation, mixed with apprehension, surely washed over him. The mission was nearing its end. But the return to the surface was not a simple act. His body, adapted to the unique conditions of the subigloo, needed careful reintroduction to the terrestrial world. The long process of decompression awaited. A final, critical test. What would it feel like to once again breathe unrecycled air, to feel the sun on his skin? The unknown lingered. The moment arrived. A slow, meticulously planned ascent. Each stage of decompression carefully managed to prevent the potentially fatal consequences of the bends. The water grew lighter, the world outside the porthole regaining color. It was a rebirth. Emerging from his steel cocoon, he was greeted by the surface world, transformed, yet familiar. The physical act of re-entry was complete. But the process of reintegration, for both his body and mind, had only just begun. The immediate aftermath revealed the profound impact of his time beneath the waves. His muscles were weaker, his bones less dense. The physiological changes were undeniable, a stark testament to the body's rapid adaptation to an environment it wasn't designed for. But equally remarkable was its capacity for recovery. Over time, with rehabilitation, his body began to reclaim its strength. A living lesson in human plasticity, and the vital role of preventative measures in such missions. The mental landscape, too, had been reshaped. The experience of profound isolation and sensory deprivation left an indelible mark. Yet, he emerged with an enhanced understanding of his own psychological resilience. He learned the critical importance of mental fortitude, routine, and purpose in extreme confinement. These insights were invaluable. They offered a blueprint for designing future habitats, for training astronauts, for ensuring the psychological well-being of those who venture into the void. Dr. McInnes's 73 days underwater profoundly influenced how we prepare for long-duration space missions. The data on bone density loss and muscle atrophy directly informed countermeasures for astronauts, like specialized exercise routines. His psychological observations became cornerstones for crew selection and support programs. The subigloo experiment wasn't just about exploring the ocean, it was about preparing humanity for a future among the stars. Our reach into space owes a quiet debt to this journey beneath the waves. The story of Dr. Joe McInnes and his 73 days in the subigloo is more than just a tale of extreme endurance. It's a testament to human curiosity, to the relentless drive to push beyond perceived limits. He proved that humanity could not only survive in profoundly alien environments, but adapt, learn, and grow. His mission changed the future of survival research, offering critical insights into both deep-sea exploration and the grander ambition of space travel. He dove deep so we could look further.